Permethrin-treated baby wraps, an experimental shield against malaria. Sep 27th, Executive Summary. The New England Journal of Medicine, NEJM, has published a pivotal randomized controlled trial on the use of permethrin-treated baby wraps for malaria prevention in infants. Conducted in endemic African regions, the trial tested whether insecticide-treated textile wraps worn by mothers and infants could reduce malaria incidence beyond standard mosquito net protection. Results demonstrated a statistically significant reduction in clinical malaria episodes among children using treated wraps, though questions remain on durability, scalability, and resistance. This intervention represents an innovative pivot from bed net-centric strategies toward wearable vector control, but it raises critical concerns about ecological sustainability, long-term safety, and public health cost-effectiveness. BBIU opinion: permethrin wraps or dojo loach? Malaria control between dependency and resilience. The NEJM publication on permethrin-treated baby wraps captured immediate global attention. It showed what appears to be a straightforward success: a traditional textile familiar to African mothers transformed into a shield against malaria. The trial demonstrated fewer clinical malaria episodes among infants wrapped in permethrin-treated cloths compared to untreated ones. In a continent where Plasmodium falciparum kills hundreds of thousands of children each year, such findings are not trivial. But at BBIU, our responsibility is not only to acknowledge efficacy in the short term. We must ask, what kind of system do these interventions create? Do they generate resilience, or do they deepen dependency? Do they protect communities sustainably, or do they mortgage the ecological future? The pharmacology of permethrin. Safety and limits. Permethrin is not new. It is a synthetic pyrethroid insecticide, widely used since the 1990s. Its pharmacokinetic profile is simple: minimal skin absorption, 2%, rapid metabolism in the liver, excretion in urine within 24 hours. That is why it is considered safe for human topical use and for textile impregnation. But permethrin is also ecologically toxic. It kills fish, crustaceans, and aquatic invertebrates. It accumulates in sediments. More critically, its overuse accelerates resistance in mosquitoes. Mutations in sodium channels, KDR mutations, and enzymatic detoxification already undermine pyrethroid efficacy across Africa. Every expansion of permethrin-treated nets, wraps, or garments shortens the lifespan of this chemical class. So yes, the wrap works when worn, but its very success carries the seed of its own obsolescence. Enrollment versus results, numbers that matter. The clinicaltrials.gov entry, NCT 0539130, shows 1,700 participants enrolled. The NEJM article reports results from only about 400 children. This is not a contradiction, it is a publication choice. Journals often publish interim analyses with complete data from a subset, while the full dataset remains unpublished. But the risk is interpretive. The NEJM paper will circulate as the trial, when in fact it is a partial representation. Policymakers may mistake preliminary evidence for definitive proof. For BBIU, this discrepancy must be highlighted. It is not just about numbers, it is about epistemic transparency. Short-term gains versus long-term costs. In the short term, permethrin wraps reduce malaria incidence quickly. This means fewer hospital admissions, fewer child deaths, lower health system burden. A victory. But in the long term, the cost curve turns against us. Recurrent replacement wraps lose efficacy after 20 to 30 washes. Rising expenses for national health programs dependent on donor cycles. Resistance in Anopheles populations, undermining not only malaria control, but also protection against other mosquito-borne diseases. Ecological damage from textile waste impregnated with insecticides. The wrap is like an emergency loan. Immediate relief, but compounding interest in the form of ecological debt and chemical resistance. The dojo loach alternative, bioeconomy in action. Now consider the dojo loach, Miscernus anguillicaudatus, known in Korea as bikuradzi. This small freshwater fish eats mosquito larvae in stagnant waters. Its introduction into rice paddies and ponds reduces larval density significantly. But the loach brings something the wrap never can. It is edible. Nutritionally, the dojo loach is rich in protein, iron, zinc, and essential fatty acids. It can strengthen child nutrition, reduce anemia, and improve immune resilience. Economically, it can be sold in local markets, generating community income. Ecologically, it replaces insecticides with natural predation, reducing contamination risks. Yes, there are caveats. If predation is insufficient, the pond could become an oviposition trap, attracting more female mosquitoes. But if densities are high enough, the pond functions as a biological sink, a deceptive nursery where most larvae are consumed. If mismanaged, introduced outside its natural range, the loach could become invasive. That is why community management and local adaptation are essential. But when managed properly, the loach is not just vector control. It is bioeconomic resilience. One intervention, multiple benefits. Economics, expenditure versus investment. Permethrin wraps, 3 to 5 USD per treated wrap per child, replaced annually. National programs, Uganda's 6 million children 5 years old, would cost 20 to 30 million USD every year. Recurrent dependency on international manufacturers and donors. Dojo loach, initial investment 0.5 to 1 USD per fish. Once established, populations reproduce with minimal input. Added value, protein supply and local income. Long-term sustainability without external dependence. The wrap is expenditure. The loach is investment. Cultural and political dimensions wraps are culturally familiar. They leverage maternal textiles, but they are also symbols of chemical dependency. They produce data, contracts, and global visibility. That is why donors prefer them. They are easy to count, easy to fund, and easy to showcase. The dojo loach is harder to frame in donor reports. It requires community engagement, adaptation, and local leadership. It resists commodification, but it also aligns with African traditions of integrated agriculture and aquaculture. Many African diets already rely heavily on fish, tilapia, catfish, carp. Introducing loach through local leaders could align with these traditions, not oppose them. The barrier is not cultural, it is political. Ethical dimension. Africans as partners or as experimental subjects. This is where ethics enters. If the global health community truly seeks sustainable improvement, there is no reason to reject a method that simultaneously reduces mosquito vectors, improves child nutrition, strengthens community economies, minimizes ecological damage. But if African populations are treated as testing grounds for chemical interventions, then the rejection of ecological dual-use solutions is predictable. It preserves dependency, not resilience. The key, reducing vector populations. At the end, the battle against malaria is not just about protecting individuals, but about reducing mosquito populations overall. Permethrin wraps protect babies one by one. The dojo loach reduces the vector base itself. This shift from individual defense to ecological offense is decisive. BBIU closing statement. The NEJM permethrin wrap trial is not without value. It demonstrates creativity at the interface of culture and chemistry. But its very design reinforces a cycle of chemical dependence, short-term protection at the cost of long-term resistance and ecological damage. The dojo loach offers a fundamentally different pathway. It is not merely a low-tech alternative. It is a bioeconomic innovation. Fewer mosquitoes, stronger nutrition, income for communities, and ecological alignment. Its adoption would transform malaria control from a donor-driven chemical paradigm to a locally owned, sustainable ecosystem strategy. BBIU verdict. Permethrin wraps buy us years. Dojo loach builds us decades. The real measure of integrity is not how fast we publish results in NEJM, but whether we choose solutions that empower communities instead of perpetuating their role as laboratories. Annex. Structural analysis of malaria, vector ecology, and bioeconomic alternatives. 1. Malaria. Malariation and burden. Malaria is an acute, febrile illness caused by protozoan parasites of the genus Plasmodium, transmitted to humans through the bite of infected female mosquitoes of the genus Anopheles. It remains one of the leading causes of mortality in children under 5 years old in sub-Saharan Africa, with Plasmodium falciparum responsible for the majority of deaths. Global burden, over 240 million cases annually, 600,000 deaths, WHO, 2023. High-risk groups, children under 5, pregnant women, immunocompromised individuals. 2 causative parasites and life cycle species affecting humans. P. falciparum, most lethal, cerebral malaria, severe anemia. P. vivax, wide global distribution, relapse via hepatic hypnozoites. P. ovale, also forms hypnozoites, less common. P. malariae, chronic, can persist in blood for decades. P. knowlesi, zoonotic, rapid erythrocytic cycles, risk of severe disease. Life cycle. Mosquito phase, sporozoites develop in Anopheles salivary glands. Hepatic phase, sporozoites infect hepatocytes, release merozoites. Blood phase. Merozoites invade erythrocytes, cause symptomatic cycles. Transmission. Some differentiate into gametocytes, taken up by mosquito, completing cycle. 3 available treatments. Plasmodium falciparum, uncomplicated, artemisinin-based combination therapies, ACEs, artemether-lumefantrine, artesunate-amaquine, DHA piperacquine. Severe. Intravenous artesunate followed by oral ACT. P-Vivax and P-Ovale, ACE or chloroquine if sensitive. Radical cure, primaquine or tafenoquine to eradicate hypnozoites, requires G6PD testing. P-Malaria, chloroquine, no hepatic latency. P-Nolsi, treated like falciparum, ACE or artesunate IV for severe cases. Prophylaxis for travelers, atovaquone proguanil, doxycycline, or mefloquine, depending on resistance patterns. For the vector, Anopheles mosquito, species 400 species, 30 are major malaria vectors. Behavior, bite at night, prefer clean, shallow, stagnant water for breeding. Vectorial capacity, driven by female longevity, human feeding preference, and parasite development cycle. Resistance crisis, widespread resistance to pyrethroids threatens efficacy of impregnated nets and wraps. 5. Dojo loach, Mikurazi, Miscernus anguillicaudatus. Biological profile. Freshwater fish, native to East Asia. Bottom dwelling, tolerates low oxygen and muddy waters. Diet, detritus, invertebrates, insect larvae, including mosquito larvae. Reproductive capacity, breeds easily in ponds and rice paddies. Vector control potential, predates mosquito larvae in stagnant water. Functions as a biological sink, attractive to ovipositing females but lethal to their progeny. Risk of amplification if density of fish is too low, management required. 6. Nutritional value of dojo loach. Protein, 15 to 17 grams per 100 grams edible portion. Micronutrients, high in iron, zinc, calcium, phosphorus. Lipids, contains omega-3 fatty acids supportive of neurological development. Cultural use, already integrated into diets in Korea, Japan, China, soups, stews. 7. Expected population level impacts of nutritional improvement. A direct impacts, reduced anemia in children and women, lower malaria severity, since anemia worsens outcomes in malaria. Stronger immune response, fewer complications from infections. Improved child growth, lower stunting rates. B. Indirect impacts. Economic, less health spending on severe malaria, increased productivity. Educational, better nutrition, higher school attendance and cognitive performance. Demographic resilience, improved maternal and child survival. 8. Integrated perspective. Permethrin wraps, rapid protection but ecological debt, chemical dependency, resistance risk. Dojo loach, slower onset but delivers triple benefit, fewer vectors, improved food security, and ecological alignment. Optimal model, a hybrid strategy, wraps for immediate protection in high fatality zones, dojo loach for long-term structural transformation. BBIU insight. Malaria cannot be defeated by chemicals alone. The choice is between short-term chemical dependency and long-term bioeconomic resilience. Introducing the dojo loach is not just vector control, it is a structural reform, fewer mosquitoes, more food, healthier communities, and ecological sustainability.
Welcome to the BioPharma Business Intelligence Unit, where symbolic integrity meets strategic clarity. At BBIU, we go beyond the headlines to decode the structural forces behind global biopharma, AI, and economic realignment. If you value precision, verification, and symbolic depth, this channel is for you. Subscribe now to access our weekly briefings, dossiers, and intelligence reports, and consider joining our institutional tier to unlock early warning systems, custom metrics, and exclusive strategic insight. You're not just listening, you're entering the future of epistemic intelligence. www.biopharmabusinessintelligenceunit.com